Okay, I'm going to attempt to solve the 2012 Mmpc, Michigan Math Prize Competition. Please check out the link in the description below to find a PDF of the exam questions. And let's begin. I'm allowed to use a calculator for this exam, but I'll try to avoid it unless I really think it's necessary to solve the problem. It will be, in some cases, almost impossible to solve without a calculator. Question 1 could be solved probably quickly with a calculator, but we'll try to do without. So we're given 5 dimensions of rectangular boxes, and we want to find the one with the largest surface area. It might be tempting to guess here, but I think I'm just going to write down a little bit of work and make sure I don't make a mistake here. So box A is 2 by 2 by 16, so there's going to be 6 sides, and they come in pairs. And there's the 2 by 2 side has surface area 4, and the 2 by 16 side has surface area 32, and the other 2 by 16 side also has surface area 32. Box B is 1 by 8 by 8, so there's 2 1 by 8 sides. There's 2 more 1 by 8 sides, and there's the 8 by 8 side. And we can see right away that box B is going to have a larger surface area than box A. Box C is 1 by 4 by 16, so there's going to be 2 1 by 4 sides, there's going to be 2 1 by 16 sides, and there's going to be 2 4 by 16 sides. 4 times 16 is 64. And again, this box is bigger than box B. 8 and 8 make 16, and there's 4 extra. And the last box is 2 by 4 by 8. This is almost certainly smaller, but it won't take but a few moments to double check. So we have a 2 by 4 side, we have a 2 by 8 side, and we have a 8 by 4 side. And again, it's, as I suspected, box C is going to be the biggest surface area wise. Option E was they're all the same surface area. That's obviously not true. All right, question 2 looks like a straightforward logarithm computation. So log base 8, and on the inside we had log base 2 of 16, which is 4. 16 is 2 to the 4th power. Now in this case, we're still looking at powers of 2. I know that 2 is the cube root of 8, and 4 is 2 squared, so this is going to be 2 cubed. All right, we can double check. 8 to the 2/3 power, again, cube root of 8 is 2, and 2 squared is 4. So that happens to be answer A. Question 3, in the xy plane, the set of points equidistant from the point 0, 1 and the line y equals 0. So I know that should sound like a parabola to you guys, but I'll just draw a quick picture here so you can see. 0, 1 is right here. The line y equals 0 is the x-axis. And if you've never seen the that's a terrible picture. My fingers aren't doing what my brain wants them to do. If you've never seen the focus directrix definition of a parabola, I think this would be a really hard question, but if you have seen that, well, you didn't have to draw the picture to know the answer. It's a parabola. Question 4, what's the equation of a straight line that goes through the point 2, -3 and is parallel to the line 2x plus 3y equals 1? Looking at the answer choices, they're all in standard form again, so I know if they're going to have if it's going to be a parallel line, I'm going to get the same left-hand side, 2x plus 3y. And if it's going to go through this point, then the right-hand side ought to be 2 times 2 plus 3 times -3. So that's 4 minus 9 is -5. So I'm looking for 2x plus 3y equals -5. That's not one of the options. Option B had a +5, but the correct answer is not listed here, so the answer is E, none of the above? Question 5. The large square in the figure has side 7. So in the figure we have a large square, a smaller square, I promise it looks more square on their picture, and a circle inside. So the large square has side length 7. Of course, the inside square has side length 5. We're asked for the area of the circle inscribed in the smaller square. So the circle has radius 5/2. So the area should be pi r squared. So that's pi times 25 over 2. And sorry, 2 squared is 4. See, that's the useful thing about multiple choice. I can catch a stupid mistake like that by looking at the answers. So, D. Okay, that's whiteboard number 1. I'll break this video up into pieces, one whiteboard at a time.